imtiyaz. Sara sifa jikar connection na mesi mujhe las soz mein se. gdcprogram@gmail.com तो इसमें से लिंक पर काफी क्लिक कर ज्वाइन कर सकते हैं. Hello, good afternoon.
Hello, Dr. Anis, I've joined actually.
Thank you very much.
Yeah, thank you.
I'm just waiting for my principal sir to
Yes, no problem. Just go ahead. I think some more will join. So yeah.
Some 10-12 minutes more.
Yes, surely.
Participants are joining.
Okay.
Ma'am, if you feel any kind of problem while communication, while any problem with this link or connectivity, please do comment here.
I'll just check if my slide is going to be, you have to enable me to put the slides, no? So if you will enable me, I will share the slides. So that one thing.
Yes, ma'am, you can.
Yeah, so if you give me the permission, I will just.
Your permission has been already granted.
Is it? But it says host disabled participant screening sharing, participant screen sharing. Probably, maybe we just check that. Yeah. I think it looks like I'm able to do. I'll just see. Yeah, fine. I can do it.
Okay, ma'am.
Yeah, I think I can do it. I'll just see once, and if it's okay. Yeah, can you see?
Yes, ma'am. It is.
Okay. I'll stop for a moment, then I'll join again. Yeah.
It is all right now.
Right. Okay.
Hello.
Yes, Anis.
Irfana from Baramulla College. Is she live? Hello.
She is going to join with the name GDCW Baramulla. Hello.
Dr. Ipana, hello.
No participants are requested to mute their phone. Participants are requested to mute their phone.
Participants are requested to mute their microphone. All the participants are once again requested to mute their microphone, please. We are about to start our program. Dr. Irfana, am I audible? Principal sir, start.
Mr. Karan, start.
So, Dr. Irfana, am I audible? You please unmute yourself. Irfana, you unmute yourself, please.
Yes, sir, you are audible. You can start now your program.
Sir, shall we start?
Yes, you shall start your program.
Nisab, can you start program? Nisab.
Yes, sir, thank you. I request once again all the participants to mute their microphones. Let me start the program. In the name of Allah, the most gracious, the most merciful. Respected Principal, Government Degree College, Pulwama, Professor Farooq Ahmed Andrabi. Esteemed Principal, Women College, Baramulla. Worthy guest speaker, Dr. Rinku Verma, Assistant Professor, Department of Environment and Forestry, College of Agriculture, GKVK, Bengaluru. Faculty members from various institutions of the Valley and outside Valley, and above all, the student participants here. I wholeheartedly welcome all of you for this guest lecture program on the eve of World Ozone Day, which is being celebrated every year on this date, that is 16th September. The theme for this year is Montreal Protocol, keeping us our food and vaccines cool. Now proceeding ahead, let me invite our worthy principal, Professor Farooq Ahmed Andrabi, for a brief welcome address. Over to you, sir.
Bismillah ar-Rahman ar-Rahim. Our revered guest and the expert and the orator for the session, Dr. Renuku Verma, who is the Assistant Professor, Department of Environment and Forestry, GKVK, Bangalore. Our revered principal from Degree College, Women, Baramulla. Other dignitaries who are attending the program from various colleges from the valley and other people who are beyond this UT and student participants. Basically, 16 September has been celebrated as the World Ozone Day, and this has a history from 1994. And today we are all already in this line that we are celebrating in this today's program in light of this, and we all know what is the requirement for the livelihood, for the human life, the essentiality of this ozone layer, and what is its spectrum in terms of its width, and how it gets depleted day by day, and how the formation of the ozone holes take place, and how we are badly affected by this. I will not speak many things about it, what the hazards that will be coming if it is not cared, and what will be the ways to care it, for which we have a very renowned and expert with us. And she is joined today for the program. It is Dr. Renuka Verma. Dr. Renuka Verma, firstly, on my personal behalf, on behalf of my college, on behalf of the other people who are associated with the program, and on behalf of my collaborating college also, I welcome you wholeheartedly. You have an endeavor, and your endeavor will definitely prove very beneficial by your version that will be narrating today before the audience, though through an online mode. But I hope the purpose for which the program has been organized and you are conveying will have a very effective impact upon the audience, and these will be the ambassadors to carry the right message, and all people will work, and there will be many people who will be joining this force, how to stop this. And I now wholeheartedly pay a welcome to you, and I hope all other people will be benefited out of this program. Thank you, my dear other participants, and especially the gracious speaker of this session. Thank you once again.
Thank you very much, sir, for your words of wisdom. Before inviting our guest speaker to start her lecture for today's program, let me present a brief introduction about her education and achievements. Dr. Rinku Verma is currently working as an assistant professor in the College of Agriculture, GKVK Bangalore since 2013. Earlier, she was also teaching in the Department of Environmental Science, Bangalore University. She had her MSc and PhD in Environmental Science from Mysore University and obtained 3 gold medals for being topper at university level. She successfully completed her postdoc from Germany under German Academic Exchange Program in 2002. She had been principal investigator of many projects related to waste management, biogas production, and limnology. She had published several papers and books with national and international publishers. I hereby skip some more important achievements due to paucity of time. Without taking much of your time, let me invite my teacher and mentor and guest speaker for today's program, Dr. Rinku Verma, to start her lecture. Before, I just want to humbly request all the participants, if they have any kind of queries or questions, they are most welcome at the end of the lecture. Thank you very much. Over to Dr. Rinku Verma.
Good afternoon to one and all. First of all, I would like to thank Dr. Muhammad Anis. Thank you so much because I know he's been behind all the organization, and thank you once again. And I would like to thank the principal of the college, Dr. Farouk Ji, for giving this small introduction and introducing me to the program. Thank you very much, and I'm very thankful to both the principals of the Pulwama and the Baramulla, Dr. Professor Banu, and all the loving students and all the scholars or all the participants who have joined in. So it's immense pleasure for me to, present before you about Montreal Protocol. So I have put a lot of colorful slides, and I think that this should motivate you and make you understand, because just giving descriptions will be boring. So anyway, please get yourself motivated and see there's so many things. It's only a part of the topic which I'm going to cover on Montreal Protocol. Okay, so I'll start, just sharing the slides. So just be with me. Okay, I hope you are able to view the screen. Okay, so this is the topic, Montreal Protocol. So that's the protocol which talks about the ozone layer. So that's keeping us, our food and vaccines cool. So let's talk about this and know more what exactly this title is meaning. So hopefully you all know where Montreal is. Montreal is in Canada. Okay, so we will just go to the next slide. Yeah. Now, now talking to you about the World Ozone Day. We all know that the World Ozone Day is celebrated on 16th of September. That is today, every year. And probably like how the World Environment Day has themes, even this time the World Ozone Day has a theme. So we will just stick to this theme and be with the theme. Okay. So ozone is also, we know where the ozone is. So before telling you about ozone, it's the right and the duty of all of us who are in this world to care for her, isn't it? Because we have been sent to this world to do something. So we have come here as guests and then we get back. And during the time we are here, we are going to do some good work. Okay. So we look only to the positivity of the aspects only. Now, if you see ozone, it's O3. So you have 3 molecules of oxygen. Now, this was the ozone layer in the southern and the northern hemisphere during spring. And one was in September. And you see that is the Antarctica and the other is the Arctic region. Now, if you see in the slide, you can very clearly see that there is this ozone hole. And we all very well know where is the ozone present actually. Where is this actually? This is very much, in the stratosphere. Anyway, I come to that later. Now, we have to know that there are a lot of, air pollutants and greenhouse gases. So I'm going to come back to ozone in another few minutes. And these greenhouse gases have been really, causing a lot of issues related to climate change from many decades now. So, and maybe 4 5, yeah, I think 4 decades or even more than 4 decades. So and some of them are the air pollutants also, and they are also, we are having the greenhouse gases as well. We have the chlorofluorocarbons. Now these chlorofluorocarbons, which we call as CFCs, which you see over here, then you have polychlorinated biphenyls, fluorides, hydrocarbons, and volatile organic carbons. Now, actually, the CFCs, okay, or the HCFCs, or these groups, they are actually having the chlorine, the bromine, and the iodine. Now, they're having a long longevity, or their lifespan is for many years. Their lifetime in the environment or the atmosphere is for a very long period of time. You will be astonished that they some of these pollutants, okay, which may be useful in another application but could be a pollutant to the environment, can stay longer in the environment, even longer than the age of human beings. So you can just imagine how severe the problem could be. Now, if you see the main greenhouse gases, then you have also, apart from carbon dioxide, we know is a greenhouse gas, methane, nitrous oxide. Nitrous oxide comes from agricultural output, okay, from the fields. You add a lot of nitrogen fertilizers, right, day in and day out. We don't think of organic farming, but now many of the farmers are aware of the repercussions and they have switched over to organic farming. Now, methane comes from anaerobic decomposition, or from other areas where you have oxygen is not there. So it can be any food waste, or it can be animal waste, or it can be waste from the sewage wastewater or whatnot. So we see that these, and then you also have carbon dioxide, and that is also a greenhouse gas. And this is all, we have a lot of carbon dioxide. So we see that the best way is to sequester carbon dioxide, and green plants has the best ways to sequester CO2. But now my focus today is again on the CFCs, which are a threat to our ozone layer. So we have CFC, different types of CFC, CFC12, and different numerical values. Then HCFC is 22. So these actually, like, they have lifetime of 102 and 121 years. So this is the number of years they can be in. So that is the concern. And we already know, you are already aware that they are coming from different sources. One source is from refrigerants, then you have coolants, okay? And then you have all these in use in foams, filling foams. So these are the, and we are using them. So now coming back to the ozone layer. Now, if you look, we have been blessed with the energy which we receive from the sun, okay, and it is giving us in day and out. We have day and night, and we get enough of sun. Okay, I know the poles may receive 5 6 months there may be darkness, but otherwise the other areas do receive. And we should know that the sun's rays also have the UV radiation, which is called as ultraviolet radiations. The ultraviolet radiations are of 3 types. We have ultraviolet A, ultraviolet B, and ultraviolet C. Now, what happens is, in the stratosphere, you have this thin layer of the ozone shield, okay, that is in the stratosphere. So this acts as a protection, and it does not allow the harmful UV radiation. I would not really say it's harmful. In some way, UV radiations have also been beneficial to mankind, but everything has a limit, okay? So within the limit, but not above the limit, then it may pose even threats. And we look into the threats later, but we will first look into, okay, what Montreal Protocol did actually, what it said, and what it taught the world, and what the world came together, different countries came together and put forward in the protocol. So I move to the next slide. I hope you understood till now. So you know this, again, I'm repeating, we have the stratosphere and there you have this ozone layer. Okay, that's after the troposphere, because you have the atmosphere, the different layers of atmosphere you would have studied. And you have the troposphere, stratosphere, mesosphere. So in the stratospheric region, you have the belt or the ozone layer. Okay, naturally occurring ozone layer is present. And this is a shield for all of us. Okay, and this shield protects us from the UV radiations, which you see over here, and we saw in the other slides as well. Now, what has happened earlier is, I should say about maybe 20, 30 years ago, or say about 3 decades earlier, we used, chemicals which we were not aware, which were a threat to the environment, like chlorofluorocarbons, okay, or HCFCs. Even chlorofluorocarbons are highly toxic, even, they have, an impact. So what happens is, they possess, chlorine, fluorine, bromine. These are all the halogens, okay? They possess the halogens, and these halogens are the ones, example I give you is chlorine, okay? You've heard of chlorine. Chlorine is used to, in the tertiary treatment, or when even in the secondary treatment, we disinfect the water with small amounts of chlorine. Very, very permissible value within that range is used. So I'm talking here about chlorine. Okay, so chlorine can damage your ozone layer. Rather, I would say the halogens have the capacity to damage, and they can just devastate the ozone layer, and they can cause a hole. That's why we call as a ozone hole. You would have heard we call it as ozone hole. Okay, so the distance. I'm not talking about the distance of the troposphere and stratosphere, but anyway, you have your aircraft and all just flying just below this layer. And you can see, the surface levels of ozone and the smog and industrial uses, etc. Now, this is, you don't have to get confused in this slide. It's just to say that you have oxygen molecules, and when on oxygen, oxygen is O2, okay, and we need oxygen, enough of oxygen. Every day we take in, a lot of oxygen, and we inhale and exhale, we take out carbon dioxide. Now, and you also know during corona times, people had even shortage for oxygen. They had to be on oxygen cylinders, which was really, a big issue to really get them. So the more you plant the trees, the more you can curb all these viruses, right? So therefore, oxygen combining with O, okay, again, you get the ozone layer, and again, this can break down, and then it can again, be lost. The cycle can go on and on. Okay, so the conversion process and all these things can keep on happening. Okay, now we go to the next slide. In the next slide, what we see is the atmosphere actually contains 90% of beneficial ozone layer. Okay, and we already know that it shields us from the harmful UV radiations, and it has, saved our, the Earth for a very long time. And even today, thanks to the Montreal Protocol, everything is taken care, but we need to even more be alert and understand what needs to be done next. So there may be toxic effects on humans and vegetation, but anyway, when we know what we are using and at the right dose, will be good. Because I would always say all substances are poison, but the right dose differentiates between a poison and a non-poison. So if you take something in little, doesn't mean that it's going to be a poison. And if you overdose, then it can become a poison. Now, looking a little more into the CFCs, which is called as chlorofluorocarbons. We have furans, chlorofluoromethanes, and these are non-toxic gases that liquefy rapidly on compression. And actually, that is the reason why they are used as coolants, because they can manage the heat, they can cool, there's expansion, and all these characteristic features are available. And therefore, they are used in refrigerants and air conditioners, or in aerosol cans, and even fast food containers. And they are also emitted by jets. The aircraft, the jets which fly at a very high altitude, they also emit these gases. especially in the stratosphere, and there is where you have the ozone layer, and that's why there's some amount of disturbances causing because of these jets which fly in the stratospheric part of the atmosphere. And they also cause the greenhouse gas effect. I already told you, apart from carbon dioxide, then methane, and then you have CFCs, then you have hydrogen sulfide, water vapor. All these are greenhouse gases. And so therefore, many countries have banned CFCs and they have replaced it by HCFCs or HCF, because the reason is that CFCs may be more, problematic than compared to HCFCs, which also may be problem creating, but not to the extent that CFCs can damage the environment. So, but there are also researchers and scientists have worked on other chemicals as well, which can reduce the stress of the greenhouse gases like your CFCs, which have been a threat to the environment. Because of the greenhouse gases, our temperatures have risen actually, and that's good that we were able to bring down the levels of the CFC. So this we have to keep in mind. So CFCs are actually families of compounds which I already told you contain chlorine, fluorine, and also some amount of carbon atoms. Okay, so you have the information given here. A little more about this CFCs. Chlorofluorocarbons are in short form called as CFCs, and they are synthetic compounds. Let me tell you, they are not natural. That's why we call it man-made compounds containing chlorine, fluorine, and carbon. That's why we call them also synthetic. They are also nature. Okay, and they are not actually natural. They are prepared. That's why they are synthetic. And they've been used time immemorial from 1930s on. You can see they've been used in refrigeration. They've been used extensively in propellants and aerosols. Okay, you use the propellants, and then blowing agents for the manufacturing, for foam manufacturing, and in air conditioning. So these are the main utilities of the CFCs. And we don't go into the structure and other things, but anyway, these things at least keep in mind. Remember all this as a story. Okay, now I take you to the next phase. So this was a small introduction about the ozone layer, the stratosphere, and about CFCs. Now we come into the next part of the presentation about the Montreal Protocol. Now, why was this Montreal Protocol coming in? Actually, the Montreal Protocol addresses all about ozone layer. Okay, and this happened in Montreal. Montreal is a city in Canada. Okay, and this happened in the year 1927. You can see I have put over here, and this is the city of Montreal. So if you have not been to Montreal, we are here now in Montreal through ways and means of the picture. And it also has a university, Montreal University. It's also famous, Montreal University. Okay, so this picture was put just to make you aware and not make you forget that the summit, the program was held at the ozone layer related to the ozone depletion, etc. in Montreal in 18. It's also written here, and this is the flag of Canada. This is the flag of Canada. Okay, now we'll look in. I have some slides which will give us exactly what exactly this Montreal Protocol actually spoke about. Very interesting. Just be with me and just look it as hearing a story, and then you understand. So this actually protocol started with a global agreement to protect the ozone layer, because we were all worried because there were so many patches of ozone hole that how will we manage. And if we didn't take care of it, then all the UV radiations would have reached the earth and caused havoc and damage. And I will show you in the next forthcoming slides what are the different damages ozone can really, the UV radiation can do when the ozone layer has been, depleted. So therefore, the main success was, it was a successful environmental agreement. Today also, if you talk about Montreal Protocol, it has showed success stories, and we will see what that success stories is. Okay, So what happened is there was a united efforts so that we phase out those substances which are causing depletion of the ozone layer. So that was the main objective. What can be done? Take away those substances which are causing ozone depletion. So that is the ozone hole they are causing. So therefore, we see that every year on 16th of September, World Ozone Day actually was celebrated, and it was highlighted actually in the Montreal Protocol. That is, the Montreal Protocol does so much more. That is, such as, now I'll just read the phrase here, very interesting. Slowing climate change and helping boost energy efficiency in the cooling sectors. Now, how did this protocol actually help? How did it help in slowing the climate change? That was very important. We have to understand this protocol has helped in slowing the climate change and help in boost the energy level. That means to say, instead of using CFCs, we started thinking of using other chemicals which were not synthetic. CFCs were synthetic, but we thought of using those chemicals which were not synthetic, those chemicals which were natural, maybe those chemicals which were environmental friendly. So therefore, what happened when we were taking so much of care, the scientists, rather, the community, the industries, because it's not only the scientists alone, it's also when the awareness is done in the protocol, the industries have come forward, the countries, the nation, India has come forward. Okay, then other countries have gone forward and taken that, okay, we will not go for CFCs, we'll go for other chemicals which are less polluting. So therefore, what happened was we have boosted our energy efficiency. If we would have not taken care, probably 1/3 of our food production would have gone wasted. Because if you all know that food is so precious today, and if we do not preserve our food, we do not refrigerate our food, we cannot make it available for the other people. Even when food items go from one place to the other, which have a shelf life which is very small shelf life, it needs refrigeration, and for refrigeration you need energy, and for energy we can't use CFCs. We have to use environmental friendly techniques which are non-polluting. So therefore, slowing climate change and helping boost energy efficiency in the cooling sector, contributing to food security, was one of the very important tasks, or the emphasis given for on the Montreal Protocol. Okay, so you see here in the next, I hope you're able to understand, all of you. Okay, so therefore in the next slide, what we see here is with the Montreal Protocol, how the Earth's, ozone layer would look like, and without the Montreal Protocol, how it would look like. So if you read any article now, search or look into some internet papers published, you will see that there has been some relief from the ozone layer depletion. So but we should take care further also. We have to take care. So many ozone depleting substances warm the climate. We already know CFC warms the climate. All the greenhouse gases increase the temperature and they warm up the climate. And therefore, the agreement was to already slow the climate change. That's why we brought in all these things. Now we have another Kigali amendment to the Montreal Protocol. If I'm not mistaken, Kigali is in South Africa. If you look into the maps, you can see it's in South Africa. So this Kigali amendment to the Montreal Protocol is set to deliver even stronger climate benefits. That's why this amendment also is mentioned over here. And therefore, there was a commitment to phase down the chlorofluorocarbons. Okay, so while HFCs don't damage the ozone, so therefore instead of taking chlorofluorocarbons, the decision was, okay, look into HCFCs, which don't damage the ozone layer, or maybe partially or to a very, very less extent. So these coolants are powerful also greenhouse gases, but we see that, okay, we can change them, but we see if we were to continue them, we could avoid 0.4 degrees Celsius global temperature rise. So this is another one thing. While HCFCs don't damage the ozone layer, These coolants are powerful greenhouse gases. We already know. So therefore, if we would have not taken care, we could have, we could avoid that 0.4 degree rise in temperature of, which could cause your global, melting of glaciers. Even 1 degree rise. I was at one of the, conferences when I was there in Germany under Indo-German project in 2018. We had visited one of the conferences. Even German and the European Union were so much, they were thinking on those lines. Even if a 0.5 degree rise in temperature happens because of the greenhouse gases, then what are the problems which we are going to, face? Different parts of the globe are going to face different, problems, like maybe floods or droughts, or maybe other problems which are related to global, the glacier melting or ice melt, etc. So the Montreal Protocol of 1987 talks on all those substances that depletes the ozone layer. So we should be much aware of all those things. Now you see how everyone is trying to, take care for the ozone layer, whether it's a United Nations Environment Program, whether it's WMO, which is the World's Meteorological Organization, whether it's a government or whether any other organization, any part of the world. So everyone is coming together and thinking what really could be done. Now, coming to a little more about the Kigali Amendment, it also provided the opportunity for improved energy efficiency in the cooling sector. Okay. And that was the innovation of replacing the CFCs and the HCFCs. So therefore, there was an opportunity to, redesign air conditioning and refrigerations. So today, even when you are going to buy any of these products, you can always look for, environmental friendly. It will be written air conditioned, environmental friendly, refrigeration, environmental friendly. Okay, so those days they used the CFCs and HCFCs, but then there was a scope later to redesign and have substances which will not pollute the environment, that could use even less power, and it could expand the food chain efficiencies. Now suppose there is something which has to come to Srinagar, maybe from some other place. Okay, it's coming out from some other city, so probably it may take long time to travel. You can't airlift everything. It's not possible to airlift the products. I myself have seen, when I can understand on the hilly valleys and the hills, how difficult it is for transportation. First of all, you don't have the straight trains. It's all hilly terrains. Because when I was in Uttarakhand and when I was in some of the hills of Nainital and Solan and other places, I could really understand every product which cannot be grown in the hill on, has to come from below the valley. And for that you need the transportation, you need materials, and if they are going to perish quickly and coming from far off, you need these cold chain vehicles where you can refrigerate them, isn't it? Otherwise, they may, spoil, because there are some milk products or some soya products which actually need refrigeration. Soya also. Those who don't take milk, they take soya, or they take other products. So these also are quickly perishable. They need refrigeration. So all these things have a complete part, to play in this Montreal Protocol. So, and which is benefiting all of us actually. So therefore we see that, these food chain efficiencies without increasing the climate impacts were really wonderful. And I think you would also appreciate, because they gave that insight, they made that awareness. So the right awareness, the right policies, the right amendments are the need of the hour. If our people, you are all there, okay, we are connected because of the technology, and I don't think that you are far from me, and I think you and yourself and myself, all of you, the students, everybody, are so close to all of us. In fact, we are all very close, and we are not far because of all these technologies. So we have to actually value the technologies. Okay, so therefore, particularly in developing economies, they really have a lot of weightage because they combat food losses. And country like India, we also need to, take care of our food. Food security is another thing which we need to be aware of. So you can see the Montreal Protocol, okay, which was happening in Canada, and then you can just we go to the next. I hope you have understood what actually was the meaning. Anyway, another 1 or 2 slides will give a little more insight into this protocol. So if you look here, you see that there are natural refrigerants, and these are the synthetic refrigerants, like man-made refrigerants, which were actually not to be used, actually used formerly. And natural refrigerants can be CO2, methane, and HCs. So this would be much appreciated than CFCs, which is R12, and HCFCs, which is R22. And there are other groups, R40, 404A, R134A, R507, R407, which are under the hydrofluorocarbons. So these are all the halogen groups. So that is, you think how it was 1930s, and then we shifted from 1980s. Again, we went into HCFCs. Then 1990s again to HFCs, and then from 2005 we really made a change thanks to the Montreal Protocol, because we started using the natural refrigerants. So that was the thing. Okay, you can see, if you are not there in the Montreal Protocol, you can think that you are sitting in the Montreal Protocol, because I put a very big picture, and you can think that you are a part of the Montreal Protocol, because we are all the human beings and we have to think ourselves. So then there is some actions happening, right? Okay, so around 1/3 of the food produced globally for human consumption actually was either wasted, but largely due to access, the access to food chain were devoid, actually, which was not available. So therefore we see that, because of all, otherwise if we would have not taken care of this 1/3 food wastage, I'm sure it would have, the estimate was 8% of total greenhouse gases per annum, per year would be, from the waste sector. 1/3 of waste, food waste, if we would have lost, or if we would have not had access to this global, this cool chains, sector, the access which is coming out because of the Montreal Protocol, we would have contributed tremendously to the greenhouse gases, at least 8%. So every time we have to be very careful, we have to think very judiciously. These are again the pictures of the 1987 Montreal Protocol. And after the protocol also there are different amendments. Amendment means if there's a Montreal Protocol, okay, related to the Montreal Protocol, we'll have different amendments. Those different amendments will be further to help out that Montreal Protocol. What else can be done on same lines, where you can add something which will be again an upliftment to the Montreal Protocol. So we had the London Amendment in 1990, Copenhagen again Amendment 1992, then Montreal Amendment again happened in 1997, Beijing Amendment 1999, and Kigali Amendment 2016. That was the most recent, and that is in, if you look into the map, it's in South Africa. So you can see you have Uganda, then you have other places, Tanzania, and then you have Kigali here. Okay, so that, because you should be aware when we speak the term from which place it's coming. So these cold chain solutions are more efficient, more climate friendly, cheaper to buy and to operate. So how much of benefit, right? We want to send things from Bangalore, say, to Jammu and Kashmir in cold storage. So we have the cold storage available. Things which are not available there is going, and from there it's coming here. Like maybe you have apples. Anyway, I know apples will have a good shelf life. It can stay long. Other products. And also this benefits farmers and also the pharmaceuticals. Okay, to provide access to pre-cooling, refrigeration, because some of the medicines, they require refrigeration and storage and refrigeration transport, because sometimes medicines has to be taken from one state to the other state, and they may not be manufactured in the same area, maybe manufactured in different locations. So therefore, on the World Ozone Day, we celebrate and we acknowledge We all of us should acknowledge the Montreal Protocol and its Kigali amendments in its wider efforts to keep us our food, our vaccines cool. So if you look, this means what we are talking today about our topic. Okay, we are talking about Montreal Protocol, about keeping our foods and our vaccines cool. So that's what it is very clearly mentioned here. The slide gives you all the information. And you can see Montreal Protocol is the world's most successful agreement. And if anyone asks you which is the most successful agreement, then just without any hesitation, just say Montreal Protocol. And then if they ask you why, then you can also have the answers of, environmental friendly chemicals are used instead of very highly synthetic chemicals, which are good for, protection of the environment. Okay, so all these things. And further, what was India's role? India also has to do something, right, towards this Montreal Protocol. So 19 June 1991, India became a party to the Vienna Convention, and Vienna is the capital of Austria. 17 September 1992, India became a party to the Montreal Protocol and ratified the London Amendment, that is again Canada. And then 3rd March 2003, India ratified Copenhagen, Amendment 1992. It's again in Europe, and Montreal Amendment 1997, and the Beijing Amendment of 1999. And 1993, India's country program was prepared, and in Jan 2006, India's country program was updated. So this was what we did towards, what was India's role towards the Montreal Protocol. Then we look into the problems. So now we know what was the real problem. A little more we look what all problems CFCs can give. It release, it's once used, it's released, and it can go up till the stratosphere. Look, what is the distance of the stratosphere? Just goes to the stratosphere and it breaks down. Okay, it breaks down over there, the CFC, and it releases the chlorine from the CFC. Takes the chlorine is released from the CFC. That chlorine is again damaging the ozone layer. So atomic chlorine destroys the ozone layer and increases the ultraviolet radiation entering into the Earth's surface and increases the risk of different types of problems, which I have highlighted. Example, cancer, okay, cataract, and then so many other things which have very dangerous consequences. So you can see CFCs and the chemical formula. We don't go into details of that. You can know 11, 12, 113, 114, 115, and CFC 22. So we are not using all these at the moment. And again, a little more about it. We know it's chlorine, fluorine, and carbon compounds. And we know where it was used in solvents, in cleaning solvents, in coolants, in refrigeration and air conditioning, blowing agents, okay, and also in the production of foams, propellants, and aerosols. And their lifespan has, 20 to 100 years. They can, stay in the environment. And one CFC molecule, just one CFC molecule results in the loss of nearly 1 lakh ozone molecule. This is really mind-blowing. In a sense, you can just be, wondering, just one molecule of the CFCs can damage so many molecules of the ozone layer. So we should be so much careful. Okay, so these are again the different types of the CFCs, HCFCs, all those which have been used as refrigerants and all their, halogen compounds, the halogen groups. If you look at the periodic table, you have, the halogens, chlorine, fluorine, bromine, iodine, etc. And then again, the refrigerants, you have all these, the synthetic refrigerants. Then we know now it's not time for, we have already shifted to the natural refrigerants like ammonia, carbon dioxide, and H2O. Okay. And we have cryptogenic and non-cryptogenic. We are not going to details, but just remember natural refrigerants. And CFC is actually contributing to 13% of all the greenhouse gases. And if you see 2007 and 1992, there has been some variation, and we see it's good side because the ozone depleting substances also have, if you see in 2007, 1992, there was more, and maybe in 2007, we see some slight reduction. anyway. Then you see the synthetic refrigerants and the natural refrigerants. So we will say no to this because in 1980s all these were used, and then natural refrigerants still require manufacturing. So we hope that many industries are there, they are doing their job, and thanks to all those industries, because we need those industries. Without the industries, things don't work. Okay. And these are the, in the forms in which they come, the CFCs and different R, 22 R numerals, 123, 401A, etc. Okay. And this is the current CFCs and what are the alternatives. And now we have gone into better alternatives, whether it's refrigerants, blowing agents, or cleaning agents. So this is already told to you. So I will just go to the next slide. So again, this is the different types of CFCs and their efficiencies, etc. Okay, and then you can see CFCs, time span, how long they stay, 111 years, 74 years, 90 years, 67 years, 8 years, and halons, 110 years. So you can just see how long they are in the environment. So the effects of CFCs also are known to us. CFCs can cause unconsciousness, they can cause shortness of breath, and irregular heartbeats. It can also cause confusion, drowsiness, coughing, sore throat, difficulty in breathing, red eyes, pain. Okay. And if it comes in contact with skin, it's like a frostbite. And you all know, because you're all in very cold areas and in snow areas, how it could be the frostbite, And then it can also cause damage to the ozone layer. We already know about it. And if that comes into picture, then the UV radiation can cause other problems like cancer, okay, then cataract problems, dermatological skin related problems. All these can happen. And overexposure can also cause dizziness, loss of concentration. It can impact your central nervous system and cardiac problems, etc. Even a person can even, die. So everything, any problem, anything in your system not functioning, direct has a link to your central nervous system. Okay. And then when the central nervous system is attacked, then the coordination of your body, you'll come across patients who have some problems, and when it attacks their CNS, central nervous system, then we see that they lose their integrity, body integrity. They're not able to manage their own body. It becomes very difficult. Okay, different types of CFCs and the market value, and in kilotons, 1996, 1991, and 1996, the market value of these, And then here you see that normal conditions, we have the UVB radiations, okay, and prevention from the ozone layer. But if you have these CFCs used as coolants, as refrigerants, and foam, or other things, then you see that they are causing the problem, because the fluorine is the damage to the ozone layer. And then you have other global warming gases which can cause the problem, like chlorine, bromine, or the volcanic emissions, and other things also. So here we have to be very, very careful with this. Okay, this is only to show you how the halogen gases can get transformed into, the chemical relative halogen gases, and we don't go into details of this. And then where all it's coming from the chlorine production center. It's coming from the cities where people are using. It comes from the agriculture sector, that is methane bromide, okay, CH3 Br, and then the other sources as well from the agriculture or the water or wherever natural or artificial means. So that's what you can see very clearly. And then you can also see from 1960s to now we are here into 2021. So there has been a slight reduction is seen, but if we continue, then we can see the graph again, showing the depletion, which is a good actually trend. Maybe in the other slides it's better off explained. Again, these are already I've told you how the CFCs are getting into the environment, destroying the ozone layer, and how the UVB radiations are impacting us. Okay, so you can see here, this graph also shows you the CFC concentration of CFC 11 and what it was in 2010 and now at 2020. So there has been some good tremendous reduction has been seen. So good that there is no rise, because this is benefiting the ozone layer. Otherwise, we should have seen the ozone hole. Now, other alternatives. So I already told you, hydrocarbons such as propane and 2-methyl propane are now used as refrigerants. You can use these, okay, and they can be better. And then the other substitutes are CFCs for electronic items are carbon dioxide. CFCs for foam blowing are water, carbon dioxide, and hydrocarbons, and HCFCs. Then substitutes for CFCs in refrigeration and air conditioning. So for that, HCFCs were used initially, that is hydrofluorocarbons, but now we have hydrocarbons, ammonia is used, and substitutes for methyl bromide, we have 1,3-dichloropropane, chloropyrene, then methyl bromide and sulfuryl fluoride. These are the other substitutes. And so maybe you can think, and work is still going on for the replacement of the halons, which are used in the civilian aircrafts, if they've done something good, but these are the substitutes. You can think how to replace them. Okay, so PCBs, anyway, I'm not going into PCBs. That's maybe another time I'll talk to you about PCBs and fluorides. And aerosols, again, you have CFCs and chlorofluoromethanes, and the others are the air pollutants. And now you see that when we are protecting our umbrella, that is the ozone layer, it's like a protection. We have the umbrella and we have the rainfall. So we have the umbrella, the rain, we are protected against the rain. So we are not wet and we do not fall sick. Similarly, if you protect your ozone layer, you can get enough of, prevention from different types of problems. Like I give you an example, skin cancer, eye problems, and immunity. Otherwise, UV radiation can be a good source of vitamin D. But if you see generally in India, I really don't know what the reason is. Maybe we should really get the contacts of more physicians and telling us vitamin D, most of the Indians, when they reach 40 plus, they have the deficiency of vitamin D. And because of the deficiency of vitamin D, there are many other problems, which health problems, which come to us. Okay. So therefore, if we can realize, then we can manage the deficiency by taking in the vitamin D tablets, by meeting our physicians, and they will be the best. No self prescriptions. Meet the doctors, and then you will always be in a safer. Okay. So again, we know that how the UV radiations can play a very important role. So we go to the next. Yeah. Now I'll just be coming to my last few slides of the presentation. You know that the sun is our energy source. Without the sun, we really cannot exist. And plants need energy and photosynthesis, all that everyone knows. But we know that this is from NASA. Okay, NASA has taken the pictures from the net. That is, the energy which comes out from the sun's energy. That is the ultraviolet radiation is actually affecting also the carbon cycle. It inhibits photosynthesis. A small amount may not do any damage. I'm talking about excess of UV radiations. And then we see it impacts photosynthesis, and it also damages the phytoplanktons. And phytoplanktons are the algae. And you won't believe the algae are responsible at least to produce roughly half of the oxygen in the atmosphere. Algae are very small, they're microscopic. You may have some larger algae. You have seen the algal mats, you have the red algae, you have the green algae, okay? You have the clean algae. You have algae growing in polluted waters. They are also regarded as biomonitors of organic pollution. So these algae are also producing oxygen. We ignore them. We ignore them. We only think it's the forest and the trees. But we should also take care of the microalgae, that is the phytoplankton, which are growing in the water bodies. So the positive side of the UV radiation is it can help in degrading the colored dissolved organic matter. And it can help the bacteria to recycle the waste, and it can get into the water, and it can make light available for the aquatic flora fauna which are there in the water body, because light is very important. If the dissolved oxygen goes below zero, then we will not have fish. They won't exist in that water body. Even DO4, DO3, 2, the oxygen level starts depleting when you have chemical entry into the water body, pesticides entering, or any other waste chemicals entering into water bodies. Okay, so therefore we can take care of all this, and UV radiations do some benefit as well. So you have UVC, B and A, and you can see their wavelength 315 to 400, 280, 315, 100 and 280 nanometers. So these are the different nanometers of the UV radiation. And you can see how important also they are to the plants, depending on the morphology or the growth of the plants. So what all the requirements are with leaf size, branching, okay, or with growth related to biomass accumulation, or what other parameters are related to it. And if you have too much of incoming UV, photons, you can see even the helical structure of the DNA can also get altered. So before, you can see the DNA helical structure, and after that you can see there is a breakage. I hope you would have seen the DNA. Every cell has the DNA. In biotechnology, usually the biotechnology teachers, when they take the environmental biotechnology class, they also isolate the DNA. We did one experiment long ago in 2005 where we isolated the DNA of, I think it was, if I'm not mistaken, was it the rat or whether it was some other small animal? And we could see the helical structure in solution, but you have to follow the procedures. Please look into the web if you get the opportunity. If not, you're doing it as an experiment, but at least see somebody would have done the experiment. Look in, click the website and see how the helical structure, which our cells are made of DNA, okay? And look how they look, how they are visible. Just see, it's very interesting to see. Since we had done, I could tell you. Okay, and then you can see what are the other benefits, problems with the UV radiation. It impacts the photosynthesis and all those things, and how the other things are. Maybe we just go further. Yeah, now this is the last few slides, 5-6 slides are remaining, and then I wind up. The last part is, how these UVB radiation can damage human skin. So they can just get into your skin, they can cause damage to the epidermis, dermis, and they can even go up to the hypodermis. So therefore, you can also get problems like skin problems, or it can also, you can have skin cancers, so many other things. So I'll just give one example of my own situation. Maybe when we were just in college, and we were a part of the NCC. So we were taken out to a rock climbing program very close to Bangalore. It's near the biological park, where we have the very good animals, and we have the white tiger and all other animals here, the leopards, etc. So we were in that region, and I was exposed to the sun maybe in October, November in the noon. And we were there for this camp for 3 days. And when I was back home, when we traveled back by bus, I was looking, many people looking and staring at me. So I was wondering there's something wrong. And the first thing I did was I went to the mirror and I just looked into the mirror, and I saw a lot of patches. And those patches had become from dark red, they had deepened, and they started, changing the color. Then immediately had to go and meet the dermatologist, and the dermatologist only told me that you've been impacted by the UV radiation. This is, I can tell you the year, this was in 1991. Okay, 1991. And then I was given on some cream, and it took me 1 year to get rid of those scars, more than 8, 9 months or 10 months that those scars didn't get away from my face. So then after that, gradually it, went away. I mean, and that was, the doctor told it was because of the UV radiation. And that's what was the doctor's understanding. Probably the dermatologists are skin specialists, and they know more about than we. Now look into this slide. Now, so that's how it gets into, and it impacts your skin layers. Okay, it's UVA and UVB radiation. And even those people also who have, cataract problems. Cataract problems also would be because of the UV radiation. So it can be of aging, but I've seen people even in 40 plus, less than 45 years also having cataract. Could be because of UV. There are so many things, and you can see that you have these UV B and UVA radiations, just getting in this your cornea. Okay, so we just don't go into more details. They are all medical terminologies and other things. So, I mean, at least we should be aware. These are the things. They can be, high energy because they are UVR radiations come with very high energy levels than the visible radiation. That we have to keep in mind. So you can see these are the shortest UVC, UVB, and UVA. They are the shortest wavelength absorbed by the atmospheric ozone, UVC. UVB is the highest, has the largest effects on the top skin, okay, and causes redness, burning, and skin cancer. Probably maybe I was impacted with UVB because there's redness of skin. And then UVA. UVA is the longest wavelength, reaches deep into your skin, and it causes aging and wrinkles. Then the last few slides, I hope I'm not boring our students and our, the people who are there together. But anyway, the last slide show that you also have melanoma. So the melanoma is, you develop patches on your body, and then that can become even more problematic. And you have skin cancers, and you have photo aging, then you have burns, you have cataracts, you have ocular melanomas, and all these things, which are the causes of UVA and UVB. Now my last slide, and thank you so much. We are coming with the last slide. With all those I talked to you, UV radiations also, that is the sunlight, stimulates the production of vitamin D, okay, which promotes the formation of the healthy bones. So I think some amount of sunlight in the right proportion also is very important for us, and we should take care because vitamin D is required for all our bodies, and we should keep our health check, in control. So last but not the least, I would like to finally conclude saying we do not inherit the land from our ancestors. We borrow it from our children. That's a Native American proverb, which I really like. And I would like to conclude saying that it's always good to actually look into, going in for environmental friendly products which are beneficial to the environment, not causing any threat or any problem. So let's think about them. Let's learn good lessons from the Montreal Protocol because it taught us good lessons, and let us have such things also happening for others because success has not been only for one success doesn't mean the other successes also should replicate in other stories as well. Then we can make the world a better place to live in. So a lot of awareness and then happenings should work from. With this, I'm again very thankful to you all, beautiful listeners, the lovely good students, the faculty, the researchers, the scholars, and all the participants who are here and who are on the YouTube. And I would also like to finally conclude by thanking Dr. Mohammad Anis Masool for always being really dedicated and doing such programs, because he's doing all this makes me feel very happy, because when you have such programs, there's an awareness which goes on to everybody. They understand more. And very good to you and your team, and then Dr. Professor Farouk and Professor Bano from both Pulwama and Baramulla college degree colleges, and all your team, and so Anis, Irfan, and Muzaffar, and all the others. I hope I got their names correctly. John and Amina, etc. All of you and all the students. I don't remember all your names, but you're really wonderful. You're all very nice, because I always like students from Jammu and Kashmir. Very lovely students, very enthusiastic, very nice. So we are not far, we're very near. Thank you once again, and do visit University of Agricultural Sciences when the situations are getting better. All your good vibrations towards prayers towards, the corona bye-bye will be very good. And this will help to restore the equilibrium of the environment and the balance, which is very, very important today because everything works on balance. And if you give damage to the balance, because God has bestowed for everything, right? And if we damage it, then to bring it back to normalcy, it becomes a lot of energy, a lot of time, a lot of money goes into it. So if you can restore it right there, the amount of money also will be saved and you can restore the environmental damage. So that's what also we do in Raj Yoga and our Brahma Kumaris. We give a lot of vibrations at final destination. Okay, thank you once again. Thank you. I won't take more time. Thank you so much.
Thank you very much, ma'am, for a very interesting and informative lecture. We received a lot of compliments from the participants for your outstanding presentation. But ma'am, just spend a few minutes more. We have received many questions in our chat box. If you can see, please, if you will be able to reply a few questions in the chat box, we shall be highly thankful, ma'am.
Yes, yes. I'll just check that. Yeah, somebody's asked about can introduction of environmental risk costs on product and services such as refrigeration help in controlling their impacts on the environment? How practical is the policy? The policy only just says, see, any type of thing which you use energy consuming will use power and you will have bills. You use the refrigeration, you use the washing machine, you will have the bills every month. You'll get the electric bills, that's there. But here what happens is, on the other hand, you think of food. If you will waste food, because a lot of food are such that they require cold storage, right? So some places you can give a natural cold storage. Some areas you don't have the natural cold storage. So for that you need refrigeration. Okay, like you see different companies, the vehicles itself completely refrigerated. So there, what happens is instead of using CFCs, you'll use other techniques where you will use environmental friendly natural products or chemicals compared to the synthetic chemicals. There it will help because some things we need to use. We can't say completely ban on it. That is difficult because we need it. Some will also be debating and say we can keep the vegetables outside. Yeah, you can keep it, but milk, how long can you keep outside? Then other things, like if you want to make ice, how can you do it? Or you have to keep a matka where you keep, because some people are very possessive, they don't want to drink cold water. So it depends. To some extent we need, so for that reason. Otherwise, if those perishable food items, then like even peas, like matar we call in Hindi, or yeah, so that also you can keep for few days outside. But once you take it out and you peel out the peas, the matar or the peas, what happens is you need to keep in shelf life. You need to keep it in a refrigeration, because now you have off season, you want to matar paneer, you say you want to make that example, then you don't have, you will only get it from cold storage, and you'll have the industry or the food industry having cold storage. So for that type of food security, for preservation, we need it. Because sometimes, like see here in Karnataka, in Bangalore, Kolar, we have a lot of tomatoes. Sometimes it falls to 10 rupees or 5 rupees per kg, and farmers just throw them. They don't know anything what to do. If they can do some products which can be kept in cold storage and made into some beverage or drink and used as a tomato puree. I can't store a tomato puree. Yeah, I can use the chemicals and put all chemicals and make a tomato puree and say, okay, I can keep a tomato puree. But if I want to make it very natural, then maybe I need to keep it in refrigeration. I have to think all those lines. So that is all the things. MIT scientists have found, okay, I hope I could answer that, have found about ozone depletion in May 2021. Please explain, what does that, I didn't understand that. What MIT scientists have found about ozone depletion? I'm not really sure about that, but What I would say as an environmental scientist myself, that don't be happy with what we have already achieved somewhere, some success from the Montreal protocol. The thing is, we need to work at it. We need to use things which have been told, which are good. When we know that tobacco is not good, we don't want to use the tobacco. We can use some other things. And we know that tobacco is bad for our health, and if we use, then it will cause some cancer or throat cancer or something. And then the person is dead before even 40 years. Okay, before 40, age of 40, or before 42, 43, the person is out from this world because they didn't take care. So everything needs to take care. I'm just giving an example. Okay. Yeah. Ozone Day. Like, see, on the remembrance, because every, like World Environment Day, we have June 5th. Then we have World Forest Day, we have Ozone Day. So today is every topic, everything which has some significance. There's some day given for its remembrance, and to think about it, because every year, like you may forget, but okay, that when that day comes, you remember. Yeah, today, 16th of September, and the year is 2021, is Ozone Day. Okay, we think about Ozone Day probably maybe during this time in 1987. We know that there was this Montreal Protocol which talked about all about the ozone, A to Z. Like, you have greenhouse gas conventions, you have so many Kyoto Protocol, so many other things. Okay, so that's the thing. Yeah, why has ozone hole appeared over the Antarctica when ozone depleting substances are present throughout the stratosphere? That's a good question. I'm not sure whether I can completely answer it. Probably, the distance from the poles. The distance from the poles, the distance from the equator to the atmosphere, the distance from the tropics to the atmosphere. So all these counts. Many other things are also there, and that could be the reason, or maybe others. His question is, troposphere is not useful and stratospheric ozone is useful. What are the main differences between the stratospheric and the tropospheric ozone? They are only the layers, though I'm not, at the moment I don't teach these, but we already know that we have the bifurcations, we have the atmosphere. So we have the actual atmosphere, then you have the troposphere, then you have the tropopause, okay, then you have the ozone, that is where you have the ozone, and then you have the stratospheric layer. So these are the different layers. It's in between the tropopause and the stratosphere. We have the ozone layer, which protects us from the harmful UV radiation. But if you see, the troposphere is more closer to the atmosphere, whereas the stratosphere is much away, and where you have actually the ozone layer present, very close to it. Okay, HCFCs are only marginally better than, yes, that is true, I agree with you. HCFCs are only marginally better, but not better. They are also the problematic synthetic compounds. CFCs are synthetic compounds, HCFCs are also synthetic compounds. That's why the earlier was changing, because immediately they really didn't know which natural compounds would be better, like carbon dioxide or hydrocarbon, or other things which I've shown you in my slides. So slowly those things have been introduced now. So that is the reason we talk about this CFCs and HCFCs. Bye. Now celebrate ozone layer. Yeah, celebrate ozone day, like how we celebrate our birthdays, like how we celebrate our other anniversaries, or whatever days are there. So many days are there in the year, like, or whatever you're celebrating, or your festivals. You celebrate your festivals, you celebrate your programs. So you also have to celebrate the ozone day also, because the ozone is such an important thing. It shields us from the harmful UV radiations. And even before Anis told me 1 month back, also I was reading some literature. I thought there's really problem with the depletion of the ozone layer. But when I was just going through literature, I was so much relaxed and happy that this has tremendously reduced, and it is one of the very good things actually. So at an individual level, if you want to protect ozone depletion, very good. Whenever you bring any products, just see that they are environmental friendly product. The refrigerant should not be, having any CFCs. Make sure when you buy these in the shops, and when you go for second hand also, just check, because some are the old refrigerators. Just check, that should not be a problem. Check with the ACs, check with good models, check with standard companies. Don't buy companies which are, I don't know what I should say, not certified companies. I would really don't go for those companies which are not certified. They should have an ISI mark. Suppose you brought a product and there's a shock, or they use less of energy. It depends. Like, I just give an example. We were gifted by a roti maker. Usually we are all busy people, so we use the roti maker. But anyway, when there is a roti maker, even we prepare the chapatis or the fulkas, they were never tasting good. And then one fine day, actually it was attached to the electric plug. Luckily, I have come home. It was no intention to come home. For some reason, I have come home to put on the lights and then go back to my mom's place. I came home and I saw the sparks, and I saw fumes and other things. And really, first of all, I went and I switched off the main connection from where the electricity comes. And then I then tried to know what was the reason. I had some geyser, water geyser. I have a small geyser in my kitchen which gives me hot water, because when it's cold, I just put on the hot geyser, because I am the cook, I am the caretaker of the house, I am the servant of the house, I'm everything. So I do all my work by myself. And I think one drop of it has fallen on this roti maker, and that has caused that problem. And when I checked, it was not ISI standards. So probably this will not have any ozone related, problematic depleting chemicals. But otherwise, look at standard quality materials when you buy them, and that would be better. So and no problems should come to others. Everyone should be careful. So whenever you're out of your home, plug out. To be on a safer side, take out. Even when you're not using your, what do you call, the internet or other routers, always advisable, take it out, because if there's a lightning and thunder, that can also damage your router, but not any severe damage. Okay, so at an individual level, you can think on all these things. You can think on air conditions. You can look on not having air condition at all. You can have the natural environment. In Bangalore, I belong to North India. Like my hometown, actually, my parents are from Punjab and Delhi. But my life, my upbringing has been right in Karnataka, like from when I was a 2-month-old child. So I'm so much adjusted to this environment. And if you would put me and bring me to Kashmir and say you stay here, then for that cold and that, I don't know how I would be able to survive, because cold is never, it always is very difficult in very cold temperatures for me to, just survive and be there. So I'm never used to such an environment. Like you put a fish from one environment to the other environment, because all my life, even the year I stayed in Germany, was like, oh, when I'm going to be out. Yes. Back, I think there was a net connection problem. Okay, so therefore, if you could take care of those things, then nothing like it. I mean, you're always safe, and I hope I could answer your questions. And maybe some things, maybe you would know better than me, and maybe you could also give.
Answering a few queries from the chat box. Now, I would like to invite Dr. Irfana to present vote of thanks the yes.
Hello, am I audible to everyone?
Yes, ma'am. Thank you.
Okay, good afternoon, everyone. Um, First of all, I would say I deem it a great honor and privilege to propose the vote of thanks on this very day. Let me first start by giving glory to Almighty Allah, who gave us the opportunity to conduct this program and for making the today's program a resounding success. First and foremost, I would like to thank our special guest, that is Dr. Rinku Verma, Assistant Professor, Department of Forestry and Environmental Science, College of Agriculture, GKVK University of Agricultural Sciences, Bengaluru, Karnataka, who I think so, despite having very much busy schedule, spared the time and giving us such a beautiful and very deep presentation on this ozone day and touching all the aspects of the ozone layer, and especially giving a nice and a very beautiful presentation on the theme of the day, that is Montreal Protocol, keeping us, our food and vaccine is safe and cool. Ma'am, we really are very grateful to you, our whole team, our organizing team. We are on their behalf. I would like to thank you from the core of our heart for such a beautiful presentation. I hope our students and other participants have benefited from this lecture. Also, I would like to express our worthy principals, that is Professor Farooq Ahmad Andrabi, Principal GDC Pulwama, and Professor Hamida Bano, the principal of our college, that is Women's College Baramula, for their unstinted support on this occasion. And without their I mean to say, without their support, this program would not have been possible. And these people, they always ignite their faculty for conducting, for organizing such events, such workshops, such seminars, for the benefit of the whole community, for the benefit of their students. Thank you, sir, and thank you, ma'am, very much. Also, I would like to thank the organizing team for their valuable contribution and hard work for conducting such an event. Similarly, I would like to extend my deep thanks to all the participants and other listeners who have been so patient during the whole lecture. Again, I would like to thank the IT Department of Government Women College Baramulla for providing us the technical support during this lecture. Finally, I'll leave some inspiring quote of Martin Luther King. As per them, an individual has not started living until he rises above the confines of his individualistic concerns to the broader concerns of all humanity. And the celebration of these days, like Ozone Day, Environmental Day, Forest Day, Water Day, Earth Day, like such days, they reminds us the same lines, that we should live for the humanity, not for ourselves. These lines, I think they give us the holistic approach, how to live for the humanity. So once again, I thank all the people and all the team who have joined today and have made this program a successful one. And once again, I thank you, ma'am, for this program, for your time during the you have sparred with us. Thank you once again, and thank you all. Thank you, Anis, my colleague and my friend, I would say.
Thank you
Thank you
so
all
much,
once again.
Doctor. Thank you so much, Dr. Naik. I'm very thankful to all of you, and I thank once again Dr. Anis. And I would like to see the students. So beautiful you are. Please put on your cameras. Very nice, because it gives me very happy to see our students from Srinagar, from Kashmir, So please, you can put on your videos if it's possible for you. I'll be also happy to see you all. Very nice. Good. Very good. That's nice. Some of you can come over video. If you can come over video, it's good. Yeah, very nice. Because I feel I'm with you and you are with
Yes,
me
ma'am,
already.
we do feel this.
And yeah, when they put on their videos, then I feel that the students are just right in front of me, so I can take back those memories, and these memories will be, always in my thoughts. Once in a way, when I have to think, okay, then I say, okay, it was a nice talk to the students of Srinagar and the colleges of Kashmir. So wonderful, very nice students, really good. I really appreciate. There are some more questions, but it looks like sometime later because of time. If there is time, then I'll take. But anyway, I'm happy. There's so many girls. Wonderful. So the girls, you're a girl power. You can do so much more. Huh? कुछ करना है, कुछ छोड़ना नहीं है, करना है ना? मतलब there is so much potential in everybody. It's every human being, everyone God has given the potential. But when we realize our potential, and our thought is our potential, so stronger our potential is in our thoughts. The stronger the thoughts, the better the results. The weaker the thoughts, the weaker the results. So you keep all your thoughts quite strong and be very, very affirm that you have the capacity to do and a very strong willpower. I'm sure all students can contribute. Sitting in Kashmir and Srinagar only can contribute so much to world climate and to so many things, environmental issues. Now you see the apples are going above the temperature. You have to take it to more higher altitude. Am I right or wrong? You have to tell me,
Yes,
because
ma'am.
so you need
Yes, ma'am.
at a higher altitude, because of climate change. The apple trees which were growing at a lower altitude, I think they don't give the fruits now. You have to go at a higher altitude. So many environmental issues are there which we need to take care. And for this, we need to green the globe. Please green the globe. If you can put more plants and trees in Jammu and Kashmir, do it. Bring the forest department. If your parents are in the forest department, bring them together. Do togetherness in tree planting. And you should be the leaders. Everyone should look at the state and say, Srinagar is contributing so much to the green, and has gone 70, 80, 90% above what you are today. You should be more than that. Okay, so next time any other thing is there, I'm always there for you all, and I wish you good. And there are so many more questions on ozone depletion. Students are asking me EIA, so many things are there. EIA, I have not really checked with EIA, but usually we have environmental impact assessment for any developmental projects. It has to pass through the expert committee, and we have to check. Though I really don't do with EIA. I used to teach EIA earlier, but at the moment I teach environmental engineering and environmental pollution, and I teach disaster management and forestry. So these are the topics actually at the moment I'm teaching at the university to PG students and to the UG students. Of course, I also have visits to the village, so where we do a lot of village work also. And there was one more question, I think. For example, refrigerators is needed in a household. A deep freezer is not, but we can find freezers in many households. Freezers are most costlier with environmental cess. Yeah, it will discourage the use and thus reduce environment. Yeah, that can also be an option. You can think on many things. Like, see, in Kashmir, you have those cold storage. You can use those cold storage. What we do here is, I think even at Uttarakhand also, they make that mud, structures, and they store their grains inside, and it is kept in the outside environment because all night it is cold. I think in Srinagar, you also will be doing all those things. These are not common here, but students did some awareness, probably seeing others. But I have seen this in Uttarakhand when I was there in Solan, when I'd gone to that Himalayan Research Institute. Okay, students, I won't take much time, and thank you once again, and all the very best to everybody. Okay,
Thank
stay
you, ma'am.
safe, stay healthy, and be happy always. Thank you so much.
Thank you.
Thank you, Anis, Dr. Anis. Thank you, Dr. Anaika. Thank you, Principal. Thank you, everybody.
Thank you, ma'am. Thank you once again.
Take care. Take care. Bye-bye.
Anis, I'll be leaving. Thank you.
Okay, thank you, ma'am. You
Thank
can
you.
leave now.
Thank you, ma'am.
Thank you.